Hello friends, today I am going to reveal some true facts of our largest planet in the solar system, Jupiter. But first of all, I request you to please share and subscribe my channel for getting my informative true facts videos uninterrupted. Now Jupiter, our largest planet in solar system. Size of Jupiter, size. Jupiter is the largest planet in our galaxy, the Milky Way galaxy, named for the most power of the Roman gods. Jupiter's mass is more than double that of all other planets of solar systems combined. Jupiter's mass is more than double that of all other planets in our solar system combined. More than 1000 Earths inside the volume of Jupiter. More than 1000 Earths. Brightness. Third brightest object in our night sky. Only the Moon and Venus are brighter. Physical features of Jupiter. The largest of four gas giants, the other three are Saturn, Uranus and Neptune. Composed primarily gas and liquid and not of solid matter. Jupiter is composed of primarily gas and liquid and not of solid matter. These gas giants encompass over 99% of our solar system's planetary mass. Orbit and rotation. The planet orbits around the Sun in a slightly elliptical pattern. It completes one orbit in 4,333 Earth days, or about 12 Earth years. Jupiter rotates than any other planet in our solar system. It rotates on its axis once every 9 hours and 56 minutes. 9 hours and 56 minutes. Mass and density of Jupiter. 318 times larger than Earth. Jupiter is 318 times larger than Earth, heavier than any other planet. Density is relatively low, being composed mostly of 14% helium and 86% hydrogen. The core of Jupiter, made of heavier elements similar to those of Earth, but 20 to 30 times more massive. The core endures massive pressure, making it twice as dense as Earth's core, and large enough for Earth to fit inside of it with room to spare. The great red spot of Jupiter, it is important. The great red spot. It is a never-stopping hurricane. As at its widest diameter, it is 3 times the size of Earth. Color change from brick red to slightly brown. Drifts east and west. Always stays the same distance from the equator. Meteorology. Between 1997 and 2000, scientists saw 3 white ovals merge in Jupiter's southern hemisphere to form one large storm. In 2006, this storm turned from white to brown to red. Now red spot junior. Scientists are given a name red spot junior. Scientists believe the spot may have turned red-blue due to its size and strength, which lifts its cloud over those surrounding them. Red spot junior may indicate that Jovian planet systems may intensify by means of merger and growth of nearby stars. Red spot junior may even rival the great red spot one day in size. Temperature of Jupiter. At the top of the clouds, it is about minus 230 degrees Fahrenheit. The temperature increases as you descend, reaching 70 degrees Fahrenheit with pressure 10 times as great as Earth, where scientists speculate life may exist. At the center, it is 43,000 degrees Fahrenheit, which is hotter than the surface of the Sun. It is important. At the center, it is 43,000 degrees Fahrenheit, which is hotter than the surface of the Sun. Now temperature. It was originally thought that Jupiter radiated the same amount of heat as it received from the Sun based on Jupiter's surface temperature. But based on the Galileo and Voyager missions, we later found out that the surface was a little bit hotter than we thought, making it radiate 2 times as much heat as it receives. Now the question is whether Jupiter is a star. Jupiter is the only planet in our solar system that has its own internal energy source. It is important. Jupiter is the only planet in our solar system that has its own internal energy source. Due to this, Jupiter's temperature drops about a millionth of a Kelvin every year. It, however, is far too good to have ever become a star. The moons of Jupiter, Galileo Galilei, discovered that we today all the Galilean satellites almost 400 years ago. The moons of Jupiter were Vega 1 and 2, late 70s and early 80s. Galileo probe, late 90s. The four moons are named Io, Europa, Ganymede and Callisto. The four moons are named as Io, Europa, Ganymede and Callisto. They are easily visible with a small telescope or binoculars. 4,22,000 kilometers from Jupiter. Io is 4,22,000 kilometers from Jupiter, about 3,640 kilometers in diameter. Io is the densest of the satellite, the Galilean satellites, densest. The most geologically active object in our solar system. The most prominent surface features are active volcanoes. Active volcanoes are found in satellites of Jupiter and low Jupiter. The atmosphere is thin and made up of sulfur dioxide, result of volcanoes. Atmosphere of low satellite is made of sulfur dioxide. Volcanoes have a major effect on Jupiter's magnetosphere. The interior consists of iron sulfide core and a rocky mantle to plasma torus. Loose volcanic activity plays a major factor in Jupiter's magnetosphere. The low plasma torus is a region of heavy ions that follow the orbits of Io. I am going to repeat this. Loose volcanic activity plays a major factor in Jupiter's magnetosphere. The low plasma torus is a region of heavy ions that follow the orbit of Io. Europa, next satellite, Europa, about 6,71,000 km from Jupiter and 3,130 km in diameter. The surface consists of an icy crust with the oceans of liquid water underneath. Europa cracks in the surface may be caused by the tidal influence of Jupiter and or some kind of tectonic activity. There are also the icy equivalent of lava flows where water is spewed through the surface. The interior consists of iron sulfide core and rocky mantle. Now the satellite Ganymede, the major satellite, biggest satellite, Ganymede, about 10,70,000 km from Jupiter, 5,270 km in diameter, Ganymede. It is the largest of the Galilean moons. The scarred surface is thought to be caused by tectonic activity as well as erosion, possibly due to water. Ganymede has been suggested that water could be present under the icy crust. Water is present in the icy crust of Ganymede. The interior consists of iron sulfide core, a rocky mantle and an icy crust. Now next satellite, Callisto. Appearance is very similar to Ganymede with the exceptions of more craters and fewer fault lines. No obvious signs of geological activity is there in Callisto. The interior consists of an ice, rock core and mantle. Other moons of Jupiter. There are 16 major moons including the 4 Galilean moons. 4 of the 16 major moons have retrograde orbits. Since 1997, there has been 47 discovered by systematic surveys on Earth. Possibility of life. Due to the presence of oceans of water under its crust, it is thought that Europa could possibly develop life. Only Earth has water on or near its surface. Environment on Europa is hostile compared to Earth. Magnetic fields of Jupiter. Jupiter's magnetic field is about 14 times as strong as Earth. The strongest magnetic field except for field associated with sunspots and other small regions on the sun's surface. Its magnetic field traps electrons, protons and other electrically charged particles in the radiation belt around the planet. Magnetosphere of Jupiter. It is important. Jupiter's magnetosphere is the largest object out the universe. Magnetotails is 435 million miles long. Jupiter's magnetic field acts like a shield, protects the planet from the solar wind. The field traps the charged particles in the radiation belt. Jupiter's aurora. Trapped particles near the poles of the magnetic field creates auroras. Trapped particles near the poles of the magnetic field creates auroras. It measures about 1,200 miles long. Lights up the entire sky. It lights up the entire sky. Travels 10,000 miles per hour. Jupiter's aspects. Radio waves given off by Jupiter reach radio telescope on Earth in two forms. Burst of radio energy and continuous radiation. A strong burst occurs when low passes through certain regions in the planet's magnetic field. Continuous radiation comes from Jupiter's surface as well as from high energy particles in the radiation belts. Now, rings of Jupiter. It is important. Jupiter's three rings around its equator were discovered in 1979. Rings are more fainter than Saturn's ring, consist of mostly cloud and dust. The main ring 20 miles thick and 4,000 miles wide. Some missions to Jupiter's. Pioneer 10, launched on March 2, 1972. First spacecraft to pass through the asteroid belt and into the outer solar system. December 3, 1973 flew by Jupiter and discovered extraordinarily high radiation levels. Pioneer 11, launched April 5, 1973, flew by Jupiter December 2, 1974, studied Jupiter's magnetic field and atmosphere and photographed the planet and some of its moons. After flying by Saturn on September 1, 1979, the spacecraft continued out of the solar system. Instruments were shut down in the fall of 1995. Voyager 1. Voyager 1 launched September 5, 1977, 16 days after Voyager 2. Voyager 1 was on the fast track to fifth planet and arrived 4 months before Voyager 2. March 5, 1979, Voyager 1 takes more than 18,000 images of Jupiter and its moon. Voyager 2, launched 16 days before Voyager 1 on August 20, 1977. Arrived 4 months after Voyager 1. Voyager 2 flew by Jupiter on July 9, 1979, again taking more than 80,000 images of the planet and its moon. Voyager spacecraft discoveries. Between the two spacecraft, 3 new moons were discovered, as well as thin dark ring around Jupiter's also discovered. Voyager images of Jupiter's moon to reveal active volcanoes, the first ever discovered on another body besides Earth. Galileo, launched October 18, 1989. Jupiter probe descent, December 7, 1995. Jupiter's orbit insertions, December 8, 1995. Plug into Jupiter on September 22, 2003. Galileo was also the first spacecraft to dwell in a giant planet's magnetosphere long enough to identify its global structure and investigate the dynamics of Jupiter's magnetic field. It revealed that Jupiter's ring system is formed by dust kicked up and interplanetary meteorites smashed into the planet's 4 small inner moons, and that the planet's outermost ring is actually 2 rings, one embedded within the other, embedded rings. Ulysses, launched October 6, 1990 to study the north and south pole of the Sun. On February 8, 1992, the spacecraft flew by Jupiter and studied the planet's strong magnetic field and radiation levels. Cassini-Huygens, launched on October 15, 1997, Jupiter's flyby, December 30, 2000. Engineers used the Jupiter encounters to test the spacecraft instrument and operations. During the flyby, Cassini captured incredible images of the gas giant and its larger moons in the science plan that was coordinated with Galileo observations. New Horizons, launched January 19, 2006. Jupiter flyby, January to May 2007. It was the first spacecraft to observe the newly formed little red spot. Photographed north of the polar volcano in the middle of the eruption. Juno, planned for August 2011, will investigate the existence of the ice rock core, determine the amount of global water and ammonia present in the atmosphere. Study convections and deep wind profiles in the atmosphere, investigate the origin of the Jovian magnetic field, and explore the polar magnetosphere. In my next video, I will give some more details of our other planet of solar systems. Thanks.